Okay, welcome to a few videos on trigonometry. Let's head straight into it. And of course we need to make it maths. Okay, so for this video, we're going to be looking at finding solutions of equations. We've got quite a few examples to look through. So the first one, determine all solutions of sine theta equals a half in the interval minus 360 to 360. So jot down that graph if you want to. The idea is just we've got a visual of what's going on. So the question may or probably won't have a graph, but at least we can see what's going on. So we've got this graph, y equals sine theta, and we're trying to see when is it equal to a half. So when does it cross that dashed line? So we can see from the graph that there's some solutions. There's one, there's one, there's one, and there's one. But our view is not to do this visually or graphically, but to use the visuals just to reinforce the algebra side of things. So sine theta equals a half. So this was like if you're solving in the Cartesian plane, but the Cartesian plane would have been just 0 to 360. So we're going to find a general solution, and then we're going to use that to find all the solutions we need. So I think this is not new. The reference angle equals arc sine, or colloquially, of course, we can say shift sine, because that's what it looks like in the calculator, of a half. Now, you may know your special angles and go, oh, well, I think that's 30. And then, or you might go, was it? So, of course, you can just say, let's just pop up that trusty calculator and say, well, if we take our calculator and go, that's a little bit confusing like that, but let's take our trusty calculator here, shift sine of a half, and we get 30 degrees. So we go, okay, so our reference angle is 30 degrees. Now it said that sine theta is positive. So we know from our cast diagram that we're in, if we look at our quadrants, C, A, S, T. If sine is positive, we must be in the first and the second quadrant. And hopefully now you can see how this matches our graph, because there's the first quadrant up to 90 degrees. And here's our second quadrant solution between 90 and 180. So the two start playing together a bit better. So we can go, okay, well, 30 degrees is actually one of our answers. So theta equals 30 degrees. Or previously we would have said this as well. So theta equals 180 minus 30, which visually we can see is 150 degrees. So that's in the second quadrant. So on the Cartesian plane, 30 or 150. But wait a second, in terms of the graph, we see more clearly that the graph repeats itself. And the period of the graph is 360. So as it goes along, it's going to keep going up here. And you'll see there will be another solution at 390 degrees. And so the graph will keep going, and there'll be another one 360 degrees later. Or we could subtract. So this solution here, let's just remove those things there. This solution here, 30 degrees, could also have gone back by 360 degrees. And we'd have another solution back there at minus 330. And for our second solution at 150 degrees, so at 150, there was our solution. Again, it would repeat, and we'd have another one there, 360 degrees later, and we'd have one 360 degrees that direction too. Okay, so how do we account for those? We can say that not only is theta 30 degrees, but we could add 360 degrees. And we could add 360 degrees as many times as we want. So we're going to say 360 degrees times k, where k is an integer. In other words, we could add it once, twice, 3 times. Indeed, we could subtract it. So k could be -1 and subtract it. And the same for our second solution, plus 360 times k, where k is also an integer. So there we've got our two general solutions. And from that, we can find our specific solutions. So here we want all the answers that are between minus 360 and 360. So these are our first two, 30 degrees or 150 degrees. Now if we add 360 to 30, we're going to have gone too far, right? 390 degrees is too big, so we're not going to consider that. 150 obviously has gone too big. And if we took 150 minus 360, so 150, and we really just go and see what happens if we subtract 360, we'll be at negative 210. And that matches the graph over there. We can see that's negative 210. And if we took the other solution of 30 degrees and said, well, let's take 30 and subtract 360, we'll be back at negative 330. Okay, so visually we can see those 4 solutions and there aren't any more. Okay, so we spent quite a bit of time on this first example just to get us into it. And for the next few, we'll kind of build up our momentum as we go. So, second example, I think we'll do in the next video.